My last video got cut short. I was just about to divide both sides by 432 to get my end result right here of t equals 276 divided by 432, 5.5. Alright, and again, this problem started with decimals, so it is appropriate to leave the answer in decimals. I do not need a fraction. Okay, I could also answer this in fraction form if I chose, but it's more appropriate, since I started with decimals, to leave it in decimals. Let's look at the next page. Objective 4, identify equations with no solution or infinitely many solutions. So a conditional equation is an equation that is sometimes true and sometimes false, depending on what values are substituted for the variable. If it's a conditional linear equation, it will have exactly one solution. So the equations that we solved on the previous page were all conditional. They had one answer. If an equation does not have any solutions, we call the equation inconsistent. And say that this type of equation has no solution. So the correct answer for an inconsistent equation would be no solution. An equation that is true for all possible values of the variable is called an identity. And we say that this type of equation has all real numbers as solutions. And I would need to write all real numbers as my final answer. All real numbers as solutions. And because that's a lot to write, if you want to shorten it, there's a symbol for all real numbers. It's a capital R with a double bar. You can use this symbol to represent all real numbers. You're writing things by hand. In example 4, let's solve each of these equations and state whether it's inconsistent or an identity. So solve them like we normally would solve any equation, by combining like terms first. 3x minus 7x is negative 4x, just combining terms, plus 2, equals, I'm going to have negative 4x on the other side, plus 8. So just combine the like terms on the left-hand side and the right-hand side. Now we're going to get all the x's to the same side, and either way I go, I've got a negative 4x, so my next step would be to add 4x to both sides. When I add 4x to both sides, negative 4x plus 4x is 0, so I'm left with just the 2. Negative 4x plus 4x is 0, so I'm left with just the 8. I have no variables left. That's fine. I'm just at an impasse here where I have to decide whether or not I have a true or false statement. 2 equals 8 is not true. This is the inconsistent type. It's not true, and so the answer is that there is no solution. I can't leave it just as 2 equals 8. That's not done. That's not the answer. The answer to this would be my conclusion based upon the fact that 2 is not really equal to 8. This equation has no solution. Let's look at the next example. I'm going to start this one off with a distribute. 2 times x is 2x, plus 2 times 4 is 8, equals, let's combine our like terms right here. 4x minus 2x is 2x, and 5 plus 3 is 8. And again, all of our variables need to be moved to the same side, so either way I move them, I'm going to be subtracting a 2x from both sides. So we're going to end up with 2x minus 2x is 0, that leaves us with 8, and 2x minus 2x is 0, that leaves us with 8. This time, 8 equals 8 is a true statement. This is the case, it's an identity. Since I have an identity here, my answer is that all real numbers are solutions. So all real numbers is the actual answer to this problem. The answer is not 8 equals 8. That's the condition that told us that all real numbers was the answer. This is a true statement, whereas in the other type, that's a false statement giving no solution. So in both of these two cases, you have the same number of x on both sides of the equation, so when you eliminate the x, it eliminates from both sides, and you're left with either a true or a false statement. Let's go to the next page. Our last objective, solving an applied problem. We're looking at the formula p equals 15 plus 5d over 11. P P is the pressure of seawater in pounds per square foot at a depth of d feet below the surface. The record for breath-held diving by Francisco Ferraris involved a pressure of 201 pounds per square foot. That's the pressure. So the pressure is 201. And I'm going to use the formula to determine what the depth that he dove to was. So 201 equals 15 plus 5d over 11. I want to solve this equation for d. The first thing I need to do is to get rid of the 15. It's a positive 15, so we'll subtract 15 from both sides. So that will give us 201 minus 15 is, let's see, should be 86. 186. Forgot the 1. 186 equals 5d over 11. Now to continue solving this, this is 5 times d divided by 11. Let's go ahead and get rid of this division first by multiplying both sides by 11. So that's going to give us 5d in the right-hand side. And 186 times 11, so let's figure out what that's equal to. 186 times 11 is 2046. Alright, and then we will divide both sides by 5 to solve for d. Divide by 5. So I have 409.2. So Ferraris dove to a depth of 492. My units on this are d as in feet below the surface. Can you imagine that? Diving to 409.2 feet below the surface of the water, holding your breath. No oxygen tanks or anything. That's the answer.